There are many conflicts in the expert systems we discussed about in the previous videos. Let's see them in detail. Problems with expert systems. Expert systems come with a lot of issues. The first challenge is that obtaining the rules might be awkward. A person frequently finds it challenging to explain in plain terms what they do on a daily basis. Additionally, when different experts are consulted, their perspectives on the issue may differ, making it challenging to standardize the guidelines. They might utterly disagree on a solution as a result of this. Averaging findings might be possible in some situations, but not in others. Take a driving expert system, for instance. One expert would advise steering to the left in the event of an object directly in front, whereas another might prefer to steer to the right. It would not be wise to steer straight ahead while averaging these responses. It's also important to note that hiring human experts, especially specialists, can be expensive, especially if several are required, and that it can be difficult to schedule them and get replies from them. This entire amount of time and money is used to realize the total system. Combinatorial explosion is one of the main issues with expert systems. Simply put, the expert system grows too large. Dealing with issues and reaching a decision regardless of the circumstance is one of this system's primary goals. However, rules must constantly be introduced to account for every conceivable circumstance, regardless of how unusual it may be, in order to deal with absolutely every possibility. It is unlikely that an elephant will cross the road in front of the car. It is unlikely that there will be a lot of mud, and it is unlikely that there will be a sofa, but it could happen, and the rules must account for each of these situations. Take driving a car on normal roads as an example. Many, if not all, of these rules must be checked at each occurrence, along with any necessary conflict resolution and chaining, because some expert systems may have many thousands of rules, even to deal with something that may, to a human, be quite basic. Therefore, when there are many rules present, a system may actually be considerably slower than a human being in making a decision than it would otherwise be. Due to rules that may interact or even cancel each other out, debugging such a system to ensure that it functions in every situation can be challenging. One other thing to note is that expert systems are just one type of AI and only represent one component of intelligence generally. They specifically try to emulate the way judgments are made when faced with a variety of facts at one time and are based on expert knowledge of what to deal with them. This is the reasoning function of the human brain. It's vital to remember that these systems are more than just pre-programmed decision-making processes that always work as expected. It is feasible to use children in this manner, but it is also possible to give them the freedom to learn as they make inferences and explore their surroundings. This obviously depends on the purpose for which they are needed. We'll think about such learning in more depth later. The rules that produce the winning selected conclusion can be rewarded in the sense of making them more likely to fire and or be included in the overall conclusion the following time around if such a system draws a number of conclusions. A rule will be less likely to fire again if it leads to a conclusion that is not chosen. On the other hand, failure is punished, while success is praised. Prioritizing dispute resolution could also help achieve this.